So again, lesson 3 is on reflections. And what we want to do is really focus on understanding what a reflection is and understanding what a reflection does to the shape. So number 3 here, now 3 and 4 kind of go together. It says reflect PQR over the y-axis. Okay, I'm going to be careful that I am reflecting over the correct axes, right? So if I'm reflecting it over the y-axis, I'm going to reflect each point. Okay, so I can do it a couple ways. Easy way is to say, hey, this is 2 units on this side, so I can go 2 units on that side. And that becomes R prime. When they're further away, it's kind of more difficult. So what I could say is Q is at the point -5, 7, which means, remember, when we go over the Y, we take the opposite of our X value. So it's going to be at 5, +7. And then, I'm sorry, and that should be Q prime. And then P here is at -7, sorry, 2. Let's try that again. And so if we reflect it, if it's -7, it's 7 units to the left of the y-axis, so it's going to be 7 units to the right. P prime, and again, that's +7 too. All right, so it wants us to describe what happened to each of the coordinates. Well, I didn't write down the R coordinates, but basically notice our X values became their opposites. So I'd say, again, the X values became their opposites. And the Y values stayed the same. Okay, that is the word same there that you can't read. Okay, so the next one here says reflect our new triangle. Notice P prime, Q prime, R prime over our x-axis. All right, so I'm going to again focus on the correct line of reflection and describe what happened to each of the coordinates. All right, so I'm focusing on my new triangle here. Again, R prime is 2 units above, so we would go 2 units below, right? Now, how we denote this now is to say R double prime. We put 2 lines by it, okay? P right here, it's 2 above, we'd go 2 below, so what we notice is that P double prime is now at the point +7, -2. Okay, sorry, I squeezed it in there. Q, if we reflect it over, we're at 5, 7. Well, I'm going to bring it down here. I'm going to still say at 5, but I'm going to go down to -7. So this is going to become the point 5, -7, and that's Q double prime. Okay, so what happened? Oh, I should connect the dots here. And we're going to say what happened to our x values. Well, I didn't really do my r's again, but my 5 stayed a 5, my 7 stayed a 7. So the x values stayed the same. And the y values again, 2, -2, 7, -7 became their opposites. So it's kind of like if you reflect over the y-axis, you change the x's, right? You make them their opposites. If you reflect over the x-axis, then your y values, you flip them from positive to negative. Okay? So let's again focus on what's happening in reflection. Bella thinks that the transformation below represents a translation. Is she correct? Well, if you take this figure and you slide it over here, it sure looks like the same thing. But there's a problem, okay? Let's talk about orientation of our vertices. These are our vertices right here, right? G, H, I, J. And so if I look, G, H, I, J, or, G, H, yeah, that's right, G, H, I, J, it's going in a clockwise direction. Now, if I do the corresponding G prime, H prime, I prime, J prime, notice that my direction is now counterclockwise. So it can't be a translation because a translation preserves orientation. So is this a translation? No. The orientation of the vertices changed. So it's a reflection. I'm squeezing in. Okay, because the orientation changed, of the vertices changed, it's a reflection. Okay, so that leads us to compare and contrast here. So similarities. When we're talking about translations and reflections, similarities, they create an image that is congruent, remember the geometry word for equal, to the preimage. Okay? They create an image that is the exact same shape and size. But, okay, the difference is translations. Okay, so both do this, but translations preserve orientation. Reflections do not. So, how they're similar? Well, both of them are going to be preserve distance and angle measure because the new shape is congruent. But the difference is that translations, they keep the orientation the same. Clockwise or counterclockwise, the vertices are in the same orientation, right? They go in the same order. Reflections do not. All right, a couple more examples. It says use what you've known, so use what you've learned to show where the following points would be after a given reflection. Okay, so if we reflect it over the x-axis, okay, remember our point goes to, if it's over the x-axis, the y values become their opposite. So our x stays the same and our y changes. So A, which is at 6, 8, would become 6, negative 8. B, which is at negative 5, 1. And I'm not putting A prime or anything in front of these because we're just focusing on the coordinate, on the points, right? The order pairs. Negative 5 stays the same, but 1 becomes its opposite, negative 1. 10 stays the same, but negative 9 becomes a positive 9. That's why you don't just always make things negative. You might be like, oh, that's a negative y. Well, negative 9. No, this means opposite. Negative 4 is an positive 11. Again, becomes positive. And 7, negative 12. Now, for a reflection over the y-axis, that's where we make the x value its opposite. So this is going to become, from right here, we're ignoring this middle column here now. The preimage is at 6, 8. Well, it would go to negative 6, positive 8. We're flipping it over the y-axis, so our x value is changing. Negative 5, 1 would become positive 5, 1. 10, negative 9 would become negative 10, negative 9. Again, y value is staying the same. Negative 4, negative 11 would be positive 4, negative 11, because our y value is staying the same. Our x value is becoming its opposite. 7, 12 would become negative 7, positive 12. Okay? So if we want to write in our own words what's happening, we've kind of wrote this a lot already. So if we're doing a reflection over the x-axis, the y values become their opposite. And the x values stay the same. See if I can get this to change it all for us and fit in the box. Maybe, maybe not. Nope, okay. So I'll just move it. There we go. All right, now if we do a reflection over the y-axis, and I click the right box, reflection of the y-axis, the x values become the opposite. And the y values stay the same. All right, so just to kind of summarize, and I know, again, feel free to write what you want to write down. We've got it, right? Reflect over the x, you change the y's to their opposites. Reflect over the y, change the x's. But I want you to focus on reflections for a second. Reflections preserve distance, which basically when I say preserve distance means preserve segment length. They preserve angle measure. Okay? Actually, I'll just add on here and I'll scroll up so you can see. Do not preserve orientation. Okay, so reflections, again, another transformation. Isometry, they're not getting bigger or any smaller. That's the preserving distance and angle measure. But the way they face, their orientation does change.